Alright, we are going to get into something that a lot of people have a hard time with, and you probably haven't done it before. It's called a recursive rule or a recursive routine sometimes. Alright, a recursive rule for a sequence defines the nth term by relating it to one or more previous terms. Alright, the following is an example. So, what they always give you is this. They give you a start, and then they give you a rule. Alright, and the rule is always based off of where you start. So I'm actually going to show you, there's an example here to look through, but I'm going to come down and I'm going to show you here. So they will tell you a value of a term, in this case the first term. So my start is a first term of the number 4. And then they're going to say something kind of weird. Alright, they're going to say a rule, and it's going to have something that you've never seen before. Like, for instance, this rule over here says to find the next term, which is said like this. They say your term is found by taking your previous term, the term in front of it, and adding 5. Now, it's probably easier to see this if we place it in an actual table so you can see it. So look, for each number greater than 1, the first 4 terms, the domain of the function is, so, alright, the domain of the function is for 4 terms, 1, 2, 3, and 4. And the first number in the sequence is what they tell you. They say, you know what? We want you to start at 4. I don't know why that looks like 41. We want you to start at 4. So I'm going to come over here, and it says the first term is 4. Now watch me write this. Alright, to find the second term, right, you have to find the second term minus 1. Alright, well, the second term minus 1 is the first term, and add 5. Alright, so look what we just said. We said to get the second term, take the second term minus 1, the first term, and add 5. Well, they tell us the first term. The first term is 4. When I add 5 to that, it's 9. So I have 9. Now then look what they say here. Alright, to find the third term, right, you have the third term minus 1. This would be the third term minus 1, which is the second term. Alright, and that's all this means. It says whatever you plug in here, plug in here. So if I plug in 4 here, I'm going to plug in 4 minus 1. I just plugged in 3. So I plug in 3 minus 1, which is the second term. Well, the second term, the output for the second term we know is 9, and 9 plus 5 is 14. So I come over here and write 14. This one says, I'm going to write it down here. This one says, just so you can see the whole thing, to find the fourth term, I have to take a function of the fourth term minus 1 and add 5. Well, the output for the fourth term minus 1 is the third term and add 5. So it's really just referring me back to the term in front of it, because the third term plus 5, well, the third term is 14, plus 5 is 19. Now, the first 4 terms are 4, 9, 14, and 19. All we've really been doing the whole time is adding 5. So it's just the function notation that's a little bit weird for this recursive. Alright, they're finding a way to refer back to a previous term. There's some weaknesses in this. And let's talk about some weaknesses. Describe how to find the fourth term. Well, to find the 12th term, to find the 12th term, we would first have to find the first 11 terms, right? To find the second one, I have to find the first one. To find the third one, I have to find the second one. Well, I'd have to find terms 1 to 11 to get to the 12th term, all right? As you can see, when I get to numbers like 100, that gets pretty hard. In fact, to get to 40th term, all right, would we rather do what we just did and find the previous 39, or would you rather use an explicit rule? All right, I would rather use an explicit rule. Explicit rule, and sometimes that's called a function, explicit rule, because I would not, I'll say wouldn't, have to find the first 39 terms. That would be a pain, right? All right, so we're going to do one here. You ready? Here we go. To find the first 5 terms. So I'm going to make a little table, all right, with the first 5 terms. This is going to be term number, and this is going to be my output over here. Let's see how they listed the output. I think they have it listed as we always do, the output of a number. All right, so look, this rule here is the function of a number equals a function of the previous number, n minus 1 minus 2, right? And what they did is they tell me my first term right here. Here's my start. My first term is 35. We already found the first term. My second term, right, is a function of 2 minus 1 minus 2. Well, 2 minus 1 is 1, right? So it's a function of 1, which is 35. So that equals 35 minus 2, which is 33. Likewise, my third term is the function of the 3 minus 1. I'm just going to write second term minus 2, which is, second term is 33 minus 2, which gives me 31. And my fourth term is a function of the third term minus 2, which is 31 minus 2, which gives me 29. And my fifth term is the function of the fourth term minus 2, which is 29 minus 2. And this is so stinking easy because I've done this so much, but I remember looking at this the first time, and it was weird to look at, right? So we're going to do some more practices in class, but let's go ahead and do one more here, all right? First 5 terms here. So we're going to build another little table here. All right. And here we go. And term. Here's our function. Our function of n is equal to the function in front of it, the term in front of it, n minus 1 minus 4. And there's our outputs, f of n. So we know the first term, they give it to us. They tell us what it is. It's 45. And these don't work unless they give you a starting spot. The second term is a function of the first term minus 4, which equals 45 minus 4, which is 41. The third term is a function of the second term minus 4, which equals 41 minus 4, which is 37. The fourth term is a function of the third term minus 4, and the third term is 37 minus 4, which is 33. And finally, the fifth term is a function of the fourth term minus 4, which is 33 minus 4, which is 29. All right, there it is. I'm going to stop there, and we're going to continue graphing. Talk to you soon.